I'm going to see if I can find some service info in this Wallace Telliade Admiral TV 47 to 51. I already took out the spiral binding to make it easier so I can look at individual pages now. List all the models and chassis in here. So it's a 20B1, which is covered pages 12 and 13. Alright, so they have two versions of this. On the back of the chassis, it says Y19, so I'm guessing it's revision 19. So, and it has a 12AU7 sync separator. Alright, so that's the difference. 20B1 with 12AU7, and this is with 6AU6, so go with this one. And if I look on page 87, it lists the production run changes. So let's check that out too. Here's what they mentioned about that power transformer fuse. They added it with production run 16 or higher, so that explains the two fuses inside the high voltage cage. One is for the power transformer, one's for the flyback. Alright, well, we'll look at that later. For now, I'm just going to pull this page out and go with that. Let's see. A little inset here is for the 16-inch sets. Used a voltage doubler on the high voltage, so I don't have to worry about that. And let's see. Okay, 6K6 push-pull output. Okay, this should be it. And let's see, power supply. Right down there. That 1700 ohm resistor there, that's the huge canned ohm resistor. I looked that up in the Sam's as well, because the Sam's has a nice parts list, and I just zoned in on the looking for a power resistor with a really high wattage rating. It turns out it's 25 watts. So I looked around for replacements, and not so easy. Not if I want to go with new components. Let's see if I can dig one up. Here is what a modern 25 watt chassis mount power resistor looks like. Considerably smaller. Now, the problem is, at least in Mauser Electronics, they don't have 7 generator ohms. I think the closest I can get is 1500 or maybe 1800. And they cost about $3.50. And I would have to modify the chassis to use it. Drill a couple little holes, probably put some heatsink grease on there and mount it. So if the existing one is good, I'm inclined to leave it in. Especially because the owner of the set is local, and if it does develop a problem, you can bring the chassis back over and I will see what I can do. I suppose if it's lasted this long, who knows how much longer it will last. I'm going through now and working on a few circuits that are typically problematic, so I just want to tackle them right away. And those would be the vertical oscillator and amp, and a horizontal oscillator and amp. Vertical stuff down here. In particular, right now I'm checking a resistor which is supposed to be 6.8 mega ohms. This guy right here, blue, gray, green. Well, if I try to measure it in circuit, I get a slowly increasing value. It's starting to zero in on 2.0 meg, 2 meg, let's say. Well, that's obviously not what it's supposed to be, but I suspect it's because it's in circuit and it's capacitors and other circuitry that's affecting it. So I actually have already unsoldered one leg of the resistor. It's tedious, but if you really want to accurately check these, that's what you got to do. And now, looky what we get. 8.3, way out of spec. So that's going to get replaced. So what I do when I check resistors is I check them in circuit first. If they're higher than they're supposed to be, much higher, you know they're bad. If they're much lower, you really have to disconnect one end to be sure. And if they're pretty much dead on, there is a vague chance, it's happened to me once before, where it was actually bad, and it just so happened that the other resistances in the set made it look like it was good, but it actually drifted up really high in value. But typically, in circuit, if you measure them and they're pretty close to what they're supposed to be, they're okay, and move on and until you fire up the set and you know there's a problem. Now, I've worked on a few of these Admirals before, and I know another typically problematic area is these other power resistors. So, sand guy here actually already clipped out one end. That works in conjunction with this focus control. Worth checking because you do not want to burn out this focus control. The problem with these is you can see they get greenish on the end here. There's resistance wire wound around, I think, a ceramic core, and it's coated with sand. Well, the leads corrode on those. Probably copper oxide, and eventually they go open. I think it's supposed to be 750 ohms, so let's see what we get. 3.3K, that ain't right. Let me double check the schematic here. Okay, this set's a little bit different. On other sets it's 750 ohms, and this one it should be 3,000 ohms. So it is off, but not terribly. It's odd though for these to drift, because they really don't drift because they're wire. They're not carbon. So the fact that it's off by 10% is an odd sign. And I'm going to be replacing it regardless, because these definitely go bad eventually. Now, another problematic thing are these big 2-watt resistors. Very often drift high in value. This affects the bias on the horizontal output tube. This is the cathode bias resistor on the horizontal output tube. Either one of these go off, it affects your high voltage. So you want to check those. And this one is a bleeder off the B plus, forms a voltage divider. And when this goes way off, it affects the bias or the plate supply on various tubes and circuits and throws things off too. So let's check this guy. A little discolored, but it looks like it's red orange to me. So 22 kilo ohms, in other words. Let's check that out. Leads are a little corroded. Alright, so that's way off. Again, if it measures higher than it should be, significantly higher, you don't have to take it out of circuit, you know it's bad. There's nothing this could be connected to that would increase the resistance reading unless you had power going to the set. There are no passive components that can make a resistor check higher than it actually is. So that's off by, well, certainly more than 10%, so that's got to go. Just quickly check these other two guys. Should be 82 ohms. About 100. Not terrible, but again, that's going to affect your high voltage. Like I said, these are the critical circuits. It's worth taking the time to check these, and I'm inclined to replace them even if they were good, because I know these circuits, they run hot, they see a lot of use. You don't want these to fail or drift over time. It should be 10K. It's about 12, so it's 20% high. These are 10% tolerance, so both of these are out of spec. Not terribly. I could power it up, and I think I'll leave them in for now to power it up, and it should be good enough. But definitely, I want to replace that before I power the set up. Something else I want to take a closer look at is inside of the high voltage cage. Fairly easy to take these off. Remove a few 1/4 inch screws and carefully slide the bushing out. It fits in a notch in the high voltage cover, and there you go. I want to clean out all this dust. especially down in here. You're going to get arcing down in there from all that dust and debris that accumulates. And there's a resistor in there. It's hard to see because it's so dirty, but that's in series with the high voltage lead. And over time, especially from the presence of the high voltage, those can go funky. It's a 1 meg resistor. And there's another resistor. It's probably in parallel with the 1B3 filament supply. There's a door and high voltage filter cap. They call it doorknob cap. But what I also really want to check is this guy. Should be 8500 ohm, rated for 25 watts. I've restored 2 other, I guess they were 20A1 chassis. One of them might have been a 20B1. Regardless, they're basically the same. And those had much bigger resistors in there. Now, modern 25 watt resistors are a bit smaller, perhaps even this small. I don't have one in front of me, so I'm not quite sure. But you can see from these, the mica discs there was originally a bigger power resistor in there. So perhaps it was replaced at some point. I don't know. Here's a modern 50 watt. But I know for a fact from working on these sets and other projects that older power resistors were larger in dimension, even though the wattage rating wasn't any better. So this might be okay, but for sure one thing I can do is check the resistance on it. Well, that sure don't look right. That looks to me like it's dead open and there's a capacitor in the circuit slowly charging up. That requires a little bit better investigation. I am getting ready to place an order. I'm running low on some of my commonly used values like 0.047 microfarad film capacitors. Seems like every TV from the late 40s has about a dozen in it, so I go through those real fast. So I'm going to be placing an order. I might very well need to tack one of these on. I hope there's a modern equivalent in 8500 ohms, otherwise I'll have to do a little tinkering like I've done before, like maybe get a 10K resistor and throw another one in parallel to knock it down to 8500. I unmounted it and made sure that my clips were on there solid, and yeah, it's open. These are easy to take on and off because the threaded hole is just right in the chassis. It just screws down from the top. Some of you may recall from several of my Admiral 30A1 chassis restorations, I used some of these guys. 50 watts, 7500 ohms, and then I put a resistor in parallel with it. These same resistors are used in RCA, early RCA sets, and plenty of others. They all kind of just use the same design. Now, the curious thing is, these sets will run fine when these resistors go open. Well, except for one thing. The horizontal linearity will be complete garbage, because that's really what these are. It's, here it is, on the schematic. It's really there for linearity correction. The earlier sets, they actually had taps on them, and you just use the tap that gives you best linearity. You can think of it too as a damper load resistor because it goes right across the plate to cathode and the damper tube. So this was a 20A1. Besides, I could just pop this resistor right in there. Overkill on the wattage, but no problem with going higher on the wattage. It'll just run cooler. But 8500. Well, I'll see what Allied Electronics has to offer, so that's what I'm ordering from. Well, unfortunately, nobody seems to make an 8.5K 25 watt resistor these days. So I'll have to do a little tinkering. One thing I can do is take a 10K and put it in parallel with approximately 56K. And that'll give me pretty darn close to 8500. Another option is to take one of these guys, which are 5.6K, and put them in series with 3K, which would give me about 8.6K. So I would need a longer mounting screw, no big deal, and then do it like that, which is probably about how big the original was anyways. So I'm kind of inclined to do that. If I wanted to put them in parallel, I would do something like mount one here, and then have to tack one in parallel with it. Should be a little bit funky with the mounting. And I kind of like having them go vertical better because the heat will dissipate more readily, rather than having two in parallel side by side. You stack them up vertically, dissipates the heat. And of course for the wiring it's pretty easy. You just tack the two lugs together. Alright, so I think we'll go with that. Here they are installed and wired in. Some of that old wiring was just too difficult to try stripping and soldering back on, so I replaced some of it. And here we go. 8.51K, can't beat that. Alright, now I'm going to take these 4 screws off, rotate this under, or over rather, and check the resistors that are there and clean out all that gunk. The 3.3 ohm resistor across the filament is alright, but the 1 meg measures about 1.3, so that is going to reduce the flow to the picture tube, so definitely want to swap that guy out. I use some Q-tips and alcohol to clean off all the black crud, and there's a new 1 meg resistor, so that's all ready to be screwed back down. And I've cleaned up the rest of this, so I'll put the cover back on, and I think we're about ready for a power up. I'm getting prepared to attempt a first power up. Now in order to do that, I need to make a shorting bar because I don't have the radio that would plug in here. According to the service info, I need to short out pins B and H. But what's confusing is, if you compare the two, they show 3 circles on top and 4 on the bottom. Well, I've got the opposite. So I'm not sure why they would show it that way, but if I rotate it around, then it matches up. So I'm not quite sure why they would show it upside down, but whatever. So I needed to make myself a little shorting bar. Well, I just happened to have tested all the tubes, and I'm glad I did because I found 2 that were completely dead. Filaments were open, including a 6SG7, or rather a 6SQ7. So I scavenged some pins from it because it turns out that octal tube pins fit perfectly into these. So there is my shorting bar. In case you're ever wondering what's inside a metal tube, there you go. It's actually a glass tube, or at least the base is glass. I'm not sure about the rest of it. Well, I replaced these bad tubes with good tubes. I'm going to leave out the 2 rectifier tubes though. And I put some electrical tape on the 2 wires going to the phono. Remember, that's live AC line voltage. Don't want that flopping around. I did dig up an actual Admiral speaker. It's around here somewhere. I'll bring it in the room in a minute. I think it might actually be the correct model speaker that actually goes with this set. As for what I've done so far, well, a little bit of work in the vertical, a little bit of work in the horizontal, and I ended up leaving this power resistor in place. I will be replacing it though. I had to order up some parts because I was running low on some commonly used values, plus I ordered a few parts I think I'm going to need for this set, including some mica caps to put inside these audio IF cans. So I ordered up a replacement 3K resistor. In the meantime, we'll just go with that. Alright, so I'll clear off the workbench, hook this stuff up, and first do a continuity test to make sure I got this shorting bar in the right place. I've traced out the wiring enough that I'm pretty confident that is the correct shorting bar. On these sets, one side of the 6.3 volt filament goes right to the chassis ground, and the other side goes through this interconnect and then to the rest of the set. And one other curious thing is that the supply for the 6X5 rectifier is also controlled by that switch. So when the TV's off, all the tube filaments in the top chassis are off, and so is the 6X5. So I guess the radio just needs the 5U4 to power this stuff, including the amp and the radio. Alright, so here it goes. Got my meter across the tube filament. So I got the set turned off right now, so we got nothing, as it should be. Turn it on. Alright, cool. I got the variac turned down a bit low, so the filament juice is a little on the low side. Turn it up to about 117. And close enough. And hard to see. But yeah, the tubes are lit up. These little 7-volt tubes don't glow all that brightly, but yeah, they're lighting up. Alright. Well, so I guess there's only one thing left to do, which is to pop the rectifiers in there and give that a try. Alright, here goes nothing. I turn the lights down, keep an eye on these rectifiers when I turn this on, in case they overload. Checking one of the B+. You should call that the low B+. 6X5 doesn't look like it's glowing at all. It's curious. Pins are a little dirty. It's just making the contact in the socket. Oh, I took the currents are on this thing too. Oh, that sucker's not glowing at all. Okay, forget some of what I said a moment ago. First off, I had the shorting bar in the wrong position. Instead of the upper left, should have been lower left. Secondly, I was wrong about the filaments. Actually, most of the tube filaments are hardwired. It's these huge green wires coming off here that go basically directly to all the tubes, and it's only grounded in the upper chassis, not the lower chassis. I was kind of curious, although the two chassis I believe are connected with, well, they are with this ground strap, so effectively one side of the filament's grounded on this as well. Anyways, all of these tubes do get power all the time, except for the 6X5 and two tubes. So I trace this out more carefully, and most of the power goes straight off the filament, and it's just two heaters. That's most of the tubes. However, 6X5 filament is a separate wire, and it says here, this is a lower chassis, upper chassis. It says to pin 4 of V305 and pin 2 of V406. See that over here too in the filament chart. So most of the tube filaments, one side's all connected together, the other sides are grounded. Not these two tubes. So what are these two tubes? Well, 305 is the AGC. I'm guessing if they kill power to that, it turns off the gain on the set. But the other tube, V406, horizontal output tube, kill that, no power going to the flyback, no high voltage. So it's kind of similar to the Dumont I worked on in that when you're in AM mode or phono mode, all the tube, just about all the TV tubes are lit up, including the CRT. It's only the horizontal oscillator that's knocked out, and the turn off the AGC, I guess. So you're wearing out your tubes when you listen to the radio. The reason I think they did that is the one combo set I know of, which is right over here, GE802. This definitely cuts all the filament juice to the TV when you're listening to the radio. But that is a huge honking switch, and I heard it's a known failure point because you got to switch a lot of amperage. So I think what they do on this is they can use cheaper switches or have a little less chance of failure if they switch much lower current. So they leave most of the tubes lit up. You can see how thick these wires are. You can imagine you got amps going through that, and if you have a switch turning all the time on like a little 3 or 4 position mode switch, you're going to burn out the contacts on that switch. So they just do a minimal amount of current switching to disable the TV. Anyways, tested the 6X5. It's fine. I'll try powering this up one more time. Yep, 6X5 is glowing this time. And hey, we have a raster. Kind of surprised a little bit because I had moved the ion trap a bit. I was cleaning it. Loosening it up now so I can manipulate it a little. Looks like actually where I had it was pretty good. That's probably about the brightest position. Focus is terrible. Notice the focus control is actually not really doing much of anything. I hope it's not open. Another common failure point in these sets. Okay, well that's good. Next I'll dig up a speaker and see if we can get some sound. Here's the aforementioned speaker, which actually came out of an Admiral combo set. That's why I think it's very similar to, if not identical to, the speaker that actually goes with this set. Alright, so here we go. Turn my radio off so I don't get confused by that. I'm not hearing anything. That would probably help if I actually plugged the audio cable into the lower chassis. Nothing though. Should have heard some static crackles. I plugged that in. It's not what I was expecting, because I actually have recapped the lower chassis. Thought I'd at least get a hum out of the speaker. Of course, the speaker could be bad, so I've never actually used it before. Oh, looks like the tuner's doing something. That's a good sign. picking anything up. I tried a different speaker that I know is good, and no, absolutely nothing. Not even a crackle. So, I got a lot of stuff to investigate. A lot of things could be wrong with the amp. Audio output transformer is a good place to start, I think. I'll ohm that out. And could have a bad focus control. I'll ohm that out as well. So I got a raster, which is great, but the the owner told me you get a raster as well. So and I know a lot of key stuff is good. Vertical oscillator transformer, vertical output transformer, horizontal output transformer, horizontal oscillator, yada yada yada. But controls, well, I have repaired one of these by popping it open, finding a break in the wire, wound suction. But let's check that before I get too caught up with that. I really have to get some sound too, so I'll focus on that. Output transformer. Well, both the audio output transformer and the focus coil ohm out okay. I went ahead and replaced that 3K power resistor, tacked a temporary one in here so the proper one shows up, but it does test okay. And I noticed when I took it out that it was cold, so I don't think any power is getting to this. And I don't think any power is getting to the amp. Now, what do you suppose those two circuits have in common? Well, here's focus control. Center tap goes over to the power supply through a resistor that goes up and over to a capacitor and to the center tap on the audio output transformer. So what do you bet that there's no power here or there's a problem with that cap, which would certainly affect both circuits. So let's see if I can track down that cap and maybe cut the lead to it, test it, tack in a replacement, see what we can get. Let's see, where else does that go? Gotta be getting power from something somewhere. It goes up to the radio chassis. To a switch. I don't think I need to do any shorting bar on that, but I was expecting it to go to, B plus from one of these rectifiers at some point. I did a little more reading on the circuit theory and studied the schematic, and it turns out that the focus control derives its power from the audio amp because these are biased such that they pretty much draw a steady current, so it provides a stable voltage reference because you want a stable amount of current going into the focus coil so the focus stays steady. Alright, so it's actually the audio circuit that drives the focus control. They don't derive power from a common point. Alright, so let's focus on this. I just crudely jotted down the voltages here. And on pins 3 and 4, we should have 185 and 190. Well, got more like 325. Pin 3 and 326 or so on pin 4. Well, those are wildly off. 567, 000, and on pin 8 should be 12. Well, get to pin 8 and, well, 67. That sure doesn't look like a 12 to me. So what is pin 8? Well, it's cathode. Both of them tie together, 270 to ground. So not a whole lot that can go wrong there. So let's see, that's the yellow wire here. It goes down to the other pin 8. Here's a 270, which I replaced, and looky what I did. Other end isn't going to pin 8, it's going to pin 1, which is not good. In fact, I don't think pin 1's even used in this tube. So it's essentially doing nothing. So there is no path for the current to flow through in this tube because the cathodes are just floating. So how about I reconnect that 270 ohm resistor and give this another try. And here we go again. Now I'm hearing a little bit of crackling coming out of the speaker. And yes, the focus control does indeed work. See, much better focus now. So let's see if I can actually pick something up. Yes, I can. These tuner contacts must be really dirty. I only got something when I was kind of in between stations. They give you this handy access port here so you can pop these out and actually get in there. From down below you can clear the little pads, but from here you can actually clean off the contacts that they connect to. So let's see. That's 6. Should be anyways. No, nothing.
Watching that
there we
one.
go.
Doing some show prep last night.
Yeah, definitely some dirty contacts. So get this to sync. Yeah, it's horizontal. And it's vertical. Alright. Slowly, it is coming back to life. Oh no. The station has changed formats now. It's called The Game. So instead of hearing alternative rock, now I'm going to hear sports talk.
Jim Boeheim's team, if all is said and done.
Well, as long as I keep broadcasting, that's all I care about. Alright, so definitely some very good progress. Now I will start going through and replace the rest of these caps. And slowly but surely should be seeing some improvements. But things are looking pretty good as they are. This is a very weak station, so I didn't expect the video to look too good. Here's a look at that turret tuner with the pluggable coils, and see how dirty the contacts are on this side. I just cleaned this side up. Now I'll do the other side. And here's what you see inside that access port. So these are the actual switch contacts down in here. So you can shoot a little contact cleaner down in there. Helps the contacts as well. Let's see if the tuner cleaning helped any. Yeah, I'd say so. Before I had to kind of fight with this and wiggle and jiggle, but now the station comes right in. It's probably benefit from an alignment. The picture seems better here when there's not much sound. The best sound is here when the picture's weak. Now I've also hooked up a converter box over there, so again, rock solid, just Jenkins there, so glad that's all it took. Looks like the streets of San Francisco. No sound. Now we got some obvious vertical issues, and I expect these will be cleared up when I replace the electrolytic, especially the one on the cathode bypass and the vertical output tube. Picture's pretty sharp, sharp though. I can tune in some sound. There's some sound. I got the fine tuning as far left as it will go. Okay, I get sound at a couple points. So, right here. That's with the volume at 100%. This should be incredibly loud right now, instead I can barely hear anything. So as you see me do before, I'll replace the mica caps and the audio IF cans and do an alignment once I get everything else squared away. But, as far as the picture goes, that's a pretty darn good picture. Again, that's why I like these Admirals. So I guess I'll end the video here, and I'm just going to start digging under the chassis and start snipping and clipping and replacing more of those caps, and then I'll pick up probably when I want to move on to the alignment. Now you can see how good the video alignment is here. You can see all these little dots. Those are chroma dots. That's from the color info out above 3.5 megahertz. So I bet I won't need to do anything to the video IF at all, and this will have an awesome picture. Just the sound of a little tweaking.